Hello, I'm Philip Muggleston, and in this series of videos we're covering the predictive capabilities native to SAP HANA. In this video we'll be looking at time series analysis. If you've not already seen the prior videos in the series, Getting Started and Key Concepts, please do so before viewing this video, as it introduces important aspects that you'll need to know going forward. Now, exponential smoothing can be applied to time series data, either to produce smooth data for presentation or in order to make forecasts. And actually, single exponential smoothing is the simplest form of that and very, very easy to apply. It's particularly relevant to data which is fairly constant across time. So what we're going to do is see an example of single exponential smoothing. Now, from the Key Concepts video, we already use this as an example, so you've seen some of the code before. What we're going to do is create an AFL procedure using the wrapper generator. We're going to call it PAL_TS_S, so time series single smoothing. And again, we're going to call the single smooth algorithm. That's the one we're using for single exponential smoothing. And we're going to run our analysis against that. So the first thing we need to do, assuming we've not done this already, is to perform the setup process. So we'll run that. We've now created our procedure within the _sys_AFL schema. The next thing to do is to set up our input and output data. Now, to give a bit more background on this, if we were to look at the tables we have available within our application schema, we've in fact got an order facts table. If we were to have a quick look there, what we can see, we've got orders. It's pretty much transactional data across a number of months using calendar month ID, and we've got the items sold and the sales amount. And perhaps what we want to do is to look at the sales amount across time and maybe do that for a certain item or group of product items. So if we also to have a quick look at the calendar table, just so we can see that for the calendar ID we have basically about 2.5 years of data or 2 years of data, so going from 2010 through 2012 into 2013. And if we're to look at the item table, we can see that we've got a number of items and that we're grouped, for example, into cameras, items 0 to 9, and we also have TVs, which is from 30 to 39. So what we'll now do is, first thing is we're going to create a view based on looking at the order facts. Because the predictive analysis library, the single exponential smoothing capability, it requires that you have a table in a certain format with the columns in a certain order, for example, and just the columns you need. So rather than creating a new table directly, we can simply make a quick view on top of the order facts table. In this case, we're taking the calendar ID, which is references each calendar period, and we're going to sum the sales amount because we're going to group this transactional data across months. And this is where HANA really scores, because we can take very large volumes. Here we have actually about 1 million different transactions, and we can have those aggregated very, very quickly and then perform the predictive analysis on them immediately. And what we're also going to do is just filter that. So we're going to take that first group of item IDs. This is cameras. So we're going to just look at the cameras. So we create that view. And again, we create a view for the parameter table. We're going to a table for our parameter table. We create a results table for the output. And again, to make things a little bit easier to consume, we're going to create a little view that joins together the input data with the results data, so we can compare our actual sales amount with the predicted or the fitted data that we've got. So let's now run that code. We need to make sure that we're looking at the correct schema. So in this case, we're the PAL schema. We're going to create those two views, and we're going to create the parameters results tables as well. Now, in terms of the parameters, there are 3 particularly relevant values we use with single exponential smoothing. The first one refers to the raw data column. Now, effectively, if we're to look at our input data, so let's just refresh and actually have a look at the views here. We're using the input data view. what we need to specify is which of these columns has the actual numeric values we want to look at. And in this case, it's the sales amount. So that's the second column. But as the PAL typically starts counting at 0, then calendar ID is the 0 column, sales amount is column 1. So that's where we'll put our value in terms of the raw data column. So integer value of 1. Alpha refers to a smoothing factor, which allows you to fine-tune how the smoothing process works. And it's a number generally between 0 and 1. The closer it is to 0, the smoother the results are likely to be. The closer it is to 1, the greater weight on more recent changes. So sometimes if you set it very close to 1, you end up with the smoothing actually trying to chase its own tail. And the start time refers to which time period, again we look at our input data, which time period starting from 0 we want to actually start our smoothing process from. Because we don't necessarily have to start at the very first row that's in our input data. So we're now going to set up those values as our defaults. Now we've created that, we've created our tables, what we need to simply do is actually run the application. So for example, we might want to fine-tune as we run it multiple times. We wouldn't want to have to run all of this stuff up top each time. In fact, I'm just going to remove that now. We're going to run this a few times, but we just now this case need to maybe update the table, clear out the results, and actually call the procedure. So in this case, we can just simply call the procedure to do a first run, as we've already set up some default values. So if we run that, we see that the procedure runs. And now if we go to our results view and data preview, we can see that in our view we've got the input data in the first two columns, and then we've got this sales amount and predicted column. That is actually the results that we got from the predictive analysis that was just performed. In fact, if we were to go to the actual table, again let's just refresh the tables here and see the time series results table. If we were to look at this one, we can see that it's simply got the ID and the amount for the fitting that's been performed. It doesn't actually give us the input data as well, and that's why we created a view that joined together the input and the results data to put them into a single area that we can then easily analyze. So if we're to look at analysis, we can put the calendar ID on the label, we can put sales amount and the predicted amount on the axis. Very often this looks best if you do a combined bar and line. So here we can see, for example, we've got in blue the sales amount that's predicted, and in gold here we've got the actual sales amount. Actually, we did this wrong way around. Let's just put them the other way around. There. So now we can see we've got in blue the sales amount, and in gold the predicted or fitted values. We see it doesn't really fit the actual data too closely, and that's typical of single exponential smoothing, because in fact this data is kind of trending, it's increasing over time, and single exponential smoothing is not perfectly suited for that. In fact, double, which we'll see in the next video, is maybe better suited. But what we can certainly see is we've got a fit made there. And just to give you a little idea of how you can tweak some of the parameters. If, for example, we were to update the alpha value, which previously we were running, I think it was at 0.1. Now if we set it to maybe 0.5 and update our parameter table, then empty the results because it's going to override, and run the procedure again. The procedure runs again very, very quickly. And if we now refresh our view, which is on that, now we can see that the fit is much, much closer. In fact, because we've increased the smoothing factor, the alpha factor. So we can actually tweak the way that works. And we can also see that actually the first real value that we've had fitted starts from actually period number 1, which is the second period we have, and then goes forward. But if we maybe wanted to start our fitting a little bit later and have a little bit more history to it, that's where we can tweak the start time. For example, we could set that to maybe 5. If we run it with start time of 5, again empty the results table and run the algorithm, come in and refresh our view. Now we can see Actually, we're starting basically from the 5th period in our data. That's where we're creating. Again, in this case, it's maybe not such a good fit, but it actually allows us to forecast a little bit into the future. But again, we can clearly see that if data is trending, in this case increasing over time, single exponential smoothing is maybe not the best algorithm to use, because clearly it's not being able to deal with this trend, the way that the data is increasing or changing in a trending form. So in the next video, we're going to look at using the double exponential smoothing method rather than the single exponential smoothing.